Installation issues. In this nugget, we're going to look at some common issues related to partitioning hard drives, selecting and configuring a boot manager, and compiling source code and managing shared libraries. So let's get to work. All right, well, let's start out our nugget by talking about partitioning schemes, and starting with the simplest scheme that we can imagine for a Linux system, and that would be taking your hard drive and splitting it up into two partitions. One partition would be for swap space, and then the other partition would be for your whole Linux file system, which I'll just represent with a slash representing the root file system. So everything's stored in this partition. Users files, software, log files, things like that are all stored here, and then this partition is relegated to being swap space. Now this picture is not drawn to scale. It's not meant to represent that your swap space should be 1/4 of your hard drive. Typically what people do is they look at the amount of main memory that you have on your system and then they double it, and that's how they determine how much swap space to have. Remember that swap partitions can be up to 2 gigabytes large in Linux, as long as we're talking about kernel versions 2.2 or later. Okay, old kernel versions had a limit of 128 megabytes, so it's a big difference. All right, so there's our basic partitioning scheme. One partition for swap, one partition for everything else. Now let's talk about slightly more complex schemes. Let's talk about why you would want to use them and then what they look like. So basically, more complex schemes amount to assigning pieces of the file system to separate partitions. So some candidates would be the /home directory, which holds users' home directories, /user, which holds software, binaries, things like that, /var, which holds log files, mail spools, print spools. Okay, so depending on what your system is used for, any one of these could be a candidate for putting in its own partition. All right, so let's just add to our picture up here. I'm going to add to our picture another partition, and in this partition, I'm going to put the /var directory. All right, why would I want to put the /var directory in its own partition? Well, perhaps the system that we're talking about here is a print server for an office. What does the print server need to operate? Well, when you send jobs to the printer, they're spooled in the /var directory. They're held in the /var directory until the printer is ready for them. Then the printer takes them and actually prints them off. And then there's, some extra space in the var directory. New print jobs would come in, and then the var directory holds those new print jobs, and so on. By giving the /var directory its own partition, you're saying, I'm guaranteeing the /var directory will have this much space to operate. Now before, we just had this one big partition, and /var was part of that. The problem in that situation is that other things can grow in size. And as they grow in size, maybe they start to take up space and encroach on the /var directory and limit the amount of space that /var has to operate with. All right? By giving /var its own partition, you're guaranteeing the amount of space that it has to operate with. Okay, so that it can carry out its primary role as a print server, for example. All right, so that's one reason why you might want to put a piece of the file system in its own separate partition. For other directories, maybe we decided to put /user in. Maybe it's a different kind of computer. We're talking about a file server or something like that. /user is serving up all the software for a system, and so you can mount /user read-only, because everything in /user is like binaries and things. People only need to be able to read those files. Nobody needs to write them. And by mounting it read-only, you're adding an extra level of security to your software. You're making it so that people can't go in and possibly hack at the binary code and create some sort of backdoor or something crazy like that. So by mounting it read-only, you're adding an extra level of protection to your software. There's another reason why you might want to put a piece of the file system in its own partition. One last word about partitioning. Remember that each hard drive can have up to 4 partitions on it. All right, and the reason for that is because on the hard drive itself, in the very first sector of the very first track, what the disk controller sees as the first sector of the first track, there's something there called the master boot record, abbreviated MBR. And the master boot record keeps track of where these partitions are on the system. And the master boot record really can only keep track of 4 partitions. This is kind of a backward compatibility thing. When it was first designed, PCs were first designed, 4 partitions was seen as like the most that we could ever want, and now that seems ridiculously small. Okay, so in this master boot record sort of knows how things are partitioned up, and there can be up to 4 partitions. All right. Now, those 4 partitions can either be 4 primary partitions, so just what we've been talking about, you know, slash vars in one partition, swaps in another, and so on. Okay, or they can be split up as 3 primary partitions and one what is called an extended partition. So say this one is our extended partition. Then in that partition, we won't get into the details of this, but basically what that extended partition can do is be split up into many logical partitions. All right. And so it's inside of this extended partition that is information about, okay, well, actually, you know, there's 4 more logical partitions that are in here. And so for a total for the whole system of 7, 1, 2, 3, and then 4 that are in this group that are logical partitions. All right, and the partition table for this whole thing here is kept just in this sector. The master boot record doesn't know anything about that. All the master boot record knows about is that there is one partition over here, and it's an extended partition. Now let's move on and talk about bootloaders. And the 2 bootloaders that we're going to talk about are Lilo and Grub. Lilo stands for the Linux loader, and Grub stands for the Grand Unified Bootloader. Now, these 2 bootloaders have a lot more in common than they do differences, okay? Basically, what a bootloader is it's a little piece of code that's going to reside in the master boot record again, just like the partition table was in the master boot record. The loader is also in the master boot record. And when you start up your computer, the BIOS is going to look in the master boot record, and then Lilo or Grub's going to run. And basically what it's going to do is it's going to give you options of what you want to boot up. Now, if you only have one operating system installed on your computer, then the choice is going to be very simple. Do you want to boot this or not, right? So assuming you started up your computer to do something, then you're going to boot that one choice of operating system. But if you have multiple operating systems installed on your computer in different partitions or on different disks, then the bootloader is what allows you to control which one starts up. All right, so first, let's look at the info page for lilo.conf. Lilo.conf, I'm not using that on my computer. The default for Red Hat Linux is to use Grub, and that's what I'm using on my computer, but Lilo is used by lots of different Linux distributions. And here is a sample Lilo configuration file in the info page. Okay, now, before we start dissecting this, I don't want to go into too much detail, but basically the format is that down at the bottom here are these images. Okay, and these images are different operating systems that I can boot up when I start up my computer. Now, you can see here right at the top, it's saying boot equals /dev/HDA. That's telling, that's saying that Lilo is going to be installed in the master boot record of the first IDE hard disk. All right, so Lilo's in that master boot record. When it comes up, when you start up your computer, you're going to get a Lilo prompt, and from that prompt, you can start up any of these images that are listed down here. Okay, now once you get to that Lilo prompt, if you don't remember which images you had available to you, you can hit tab or question mark, I believe, to get the list of possible images that are available to you, which ones you can boot up. Anytime you make a change to the Lilo configuration file, you have to run a command called Lilo as well. Okay, and this command is located in the sbin directory. And notice it says it installs a bootloader. So basically that configuration file, you're setting up things in there. You can add different operating systems or do whatever you're going to do in that configuration file. And then you run this Lilo command. So that is installed then in the master boot record. If you forget to run this Lilo command, you could run into trouble and not be able to access parts of your hard drive or operating systems that you intend to be able to access. Okay, so that's the basic rundown for Lilo. Now let's look at Grub. Now, Grub's a lot like Lilo in that Grub can be installed in the master boot record to control the booting of multiple operating systems on your computer. So first, let's look at the grub.conf configuration file that's on my computer, and this is ridiculously simple because I only have one operating system, so I only have one entry here, and this has the title, Red Hat Linux 2.4. It tells me where the root directory is, so it's on the first IDE hard disk. That's what the 0 there represents, and the next 0 represents the first partition. So unlike when we're representing hard drives and partitions and stuff in the /dev directory, HDA there is the first hard drive. Well, here HD0 is the first hard drive. HDA1 is the first partition on the first hard drive. In the grub world, HD0, 0 is the first partition on the first hard drive. Okay, so it's telling what the kernel is and what the initial RAM disk image is and so on, and so it will boot up this 2.4.20 version of Linux. Okay, but like I said, this is ridiculously simple because I only have one operating system installed on my computer. What we're going to do now is look at the info page for Grub, and in there, in the configuration section, we'll page down there and hit enter, there is a sample configuration file here that's much more complex. Okay, so the first thing in the configuration file, it says default 0. That just says boot the first entry in the list by default. Okay, and it's going to wait 30 seconds. So what's going to happen, the grub screen's going to come up on your computer. There's going to be a whole list of different operating systems there. You just use your up arrows and down arrows to move to the one you want and hit enter. And you've got 30 seconds to do that. And if you don't do it in 30 seconds, then the first one in the list is going to be booted up. Okay, so if we go down farther here, you'll see some different titles here, some different options. Okay, and what this is saying is that GNU Herd is on their first IDE hard disk, the first partition. Okay, for GNU Linux, it is booting GNU Linux, but this time it's booting it from the second hard disk, but the first partition. So in terms of the root file system, it's saying /dev/hdb1, the second IDE hard disk, the first partition. In terms of the grub language, it's hd1, 0, and that's saying the second hard disk because the first one is hd0, and it's the first partition on that disk. Okay, so that's where to get the kernel information from, and the root file system is telling you which partition in the system here is going to be its root file system. All right, so as we go down farther, you can see here this one boots mock off of a floppy. So here it's saying the kernel is on FD0. Okay, it's saying, however, the root is on this extended logical partition here on the first IDE hard disk. So HD0, then S3 is the third logical partition on that drive. Okay, so so that's how you boot something off of a floppy. You give this directive inside of the grub configuration file. Okay, they've got more here for booting FreeBSD, booting OS2. You can see here they have the same thing for Windows, NT or Windows 95. They have a directive for that and so on. And if there's some specific thing that you want to do with Grub, if you do a search in Google and look for that, there's probably somebody who has a sample configuration file for just for what you want to do. This configuration file here is very complex. Okay, there's lots of different options, lots of different operating system choices when you boot up. Well, now what I want to do is talk about compiling programs from source code. And what we're going to do first is find some source code on the internet. And one of the nice resources to find source code to compile and add to your machine is from freshmeat.net. There's also a website out there called sourceforge.net, which has a whole bunch of software for download with mirror sites all over the world. And that's another good place to look for software to add to your system. In the next nugget, we're going to talk about compiling or adding software to your system in packages. And that's a sort of a way to, bundle everything together in a package and add it to your system. Compiling things from source code, though, is sort of a more primitive way to do things. And, everything that's in a package is also available in source code somewhere. Okay, so it's also a more universal way to add software to your system. It's like the old-fashioned way. It also gets you sort of into the mood of Linux, okay, for lack of a better term. This is how Linux was developed, right? Some people wrote some source code for the kernel and everything in between, down to, GUI interfaces, to word processors and everything else. And all that stuff is available in source code. And if you're a programmer type, then you can go in and play with that stuff, extend it, and then give it back to the community if you think your extension is worthwhile and useful to other people. Okay, so what we're going to do here, this Fresh Meat website has lots of ways to look for things. If you know the exact piece of software you're looking for, you can search for it in this box. You can also browse software, and one of the nice ways to browse things is by development status, okay, especially if you're somewhat new. You can also look in the various subcategories like artistic software, system administration utilities, and things like that, okay? But you can also browse by development status, and then you can pick things, especially if you're not very you're not into the programming part of things. You can pick things that are production stable or mature, as opposed to beta or alpha or even pre-alpha or planning. These would be more for people that are interested in taking part in some project. You can look at some things that are sort of halfway built, or they have some functionality but they're not completed yet. And so if you want to get involved in those kind of projects, then you can look for software in those categories. So I'm going to pick mature here because I want to install something on my system that is very stable. So either of the last two categories would do. And then what I can do in there is I can search for something. And what I'm going to search for is a password cracker. All right, now it's saying search for password cracker in this category. So I've already narrowed it down to development status mature. And so it said one project found within this category, and it's this program called John the Ripper. Okay, it's a password cracker to detect weak Unix and other passwords. Okay, so you can go to this link, and it'll tell you more about the software, like who wrote it, what it's all about, and so you can see the different operating systems that it's going to work for, and things like that. It also, you can then give it a little rating. So if you use this software and it did exactly what you want, then you can go back and give this a rating. And the rating is just a nice way to see, like if this was a rated 1 out of 10, then that shows that people weren't very satisfied with it. Being rated 8.4 is pretty good. Okay, so what I'm going to do then is I'm going to download the tar-gz version of this program. Okay, now tar-gz is a way to compress it, and then once we get it onto our file system, then we'll uncompress it and unwrap the tar ball, it's called. Okay, so tar is a way to archive and pack a bunch of files together into one big file. Okay, so I'm going to click on this and download it. I'm going to pause the video and come back once it's on my actual disk. Okay, so now I've put this tar-gz file into my /temp directory, and there it is. It's called john1.6.tar.gz. Now, the first thing you do to a gz file is you gunzip it. So it's gz stands for gzip, and the way you unzip that is with gunzip. Okay, so I'll say john.tar.gz. I do that, and now what I have is the actual tar file, or some people refer to this as a tar ball. Okay, so now in this tarball, this archive, is a whole bunch of files, documentation files, source code, make files, which are going to help you compile the source code, and so on. All that stuff's in this file. What I'm going to do is I'm going to copy john.1.6.tar to the /opt directory. Opt is where you can install optional software, and this is the kind of perfect thing that I would put in opt. Okay, now what you do is you unwrap the tar ball. And we'll talk about tar later in the video series in more detail. For right now, I'm just going to show you how to use it. And the way that you use it is you say tar xvf, which extracts the files from the tar ball. Okay, and as I type this, as I hit enter here, a bunch of stuff is going to scroll up the screen. These are all the files that it's unpacking. Okay, so all of these things are wrapped up in that tar file, and now what we're going to do is do a listing. You can see now there's a directory called John 1.6, so we're going to go down into that directory, and in that directory is a doc directory, a run directory, a source directory, and this readme file. Guess where we should start? Well, we should start by reading the README file, okay? And this README file is, it's a few pages long. It's telling you what it's all about. Notice that it's saying see doc/install for information about installing John on your system. I'm going to skip to that part. I did read through all this already and before, I did the video just to make sure that I understood how to use it, and I went through some of the examples and things like that. Okay, so what we're going to do then is we're going to go down into the doc directory, do an ls there, and here is a bunch of files that are all information about the program that we want to install. The one that we want to look at first is this install program. And so basically what it's saying is to compile the source, go into that source directory and type make. You'll get a list of supported systems, select one of them, and then type make system. Okay, so there we go. So that's exactly what we have to do. Now, a lot of times when you're running or when you're installing programs from source code, what you do is you get the source code, you decompress the tarball, then there's often a configure script in there. So sometimes instead of just typing make there, you'll type you'll run this configure script that will take care of some of the pre-processing steps to make. It will, check out your system and do some other things like that, and then set some environment variables, and then then when you type make, then you'll be doing the same thing we're doing here. So this is a simple program. It doesn't have a configure script. It just depends on the complexity of the program. It depends how far along it is in the code base. Obviously this is mature code, so it's simple enough that it doesn't need a configure script. Other programs you'll see won't have a configure script if they're in kind of like the beta stage, because they haven't even figured out all the bugs in the software yet, so they haven't gone ahead and made the configure script and made it very simple to install. All right, so it just depends where it is in its code cycle and how complex the program is in terms of what you have to do to it. But the main thing is read the instructions. Okay, there's the README, which is always the first thing you should read, and then that will point you to the other information that you need. Okay, so cd source, make, and then make system. Okay, so here I'm going to quit out of here. I'm going to go over then to the source directory, and in that source directory, I'm going to type make. And then it says I'll get a list of supported systems, select one, and go from there. Okay, now this scrolled up the screen, so I'm just going to go back and look. I've got a Linux x86 K6 ELF. There I am. I have an AMD K6 in my machine, and so what I'm going to do is I'm going to highlight that, and then I'm going to come back down here, and then I'm going to say make, and use the middle mouse button and say Linux x86 K6 ELF. I'm going to hit enter, and now it's going to compile this program away. All right, now once the program is compiled, then I'm going to be able to go ahead and run it. And I looked up already how to run this, but that's back in that README file. It told you how to use the program. And what you do is you go into the run directory, you type the executable name, followed by the name of a password file that you want to crack. Okay, so what I'm going to do is go back here, do a listing, go down into the run directory, do a listing there, and there's my executable. It's called John. So I'll say /John to run the executable in my current working directory, and then I give it a password file, and on my machine I'm using shadowed passwords, so the passwords are kept in etc shadow and not in etc password. All right, so notice I am the root user here to run this. Normal users wouldn't be able to run this because they wouldn't be able to read the shadow file. So I'm going to hit enter here. This is going to take a long time to run, and I only have 5 user accounts on my system. But I just want to show you one thing here. It already cracked the password, baseball, Cindy. So don't use crappy passwords, okay? This is how easy they are to break, especially if they're early in the alphabet, like Cindy's password was baseball. That's a really bad password. It took like 6 seconds to crack back with like the simplest utility that's available to everybody on the internet. Okay, so if you know, there's a lesson. I just hit Control C because I wanted to abort the session. That would take a long time to actually run through all the different things that it checks on the different accounts on my system, and I only had 5 different accounts. The big part is that it has this whole list of words, dictionary words, transpositions of dictionary words, all sorts of things it does, adding numbers in, capitals, and so on in certain places to make that work. But a very simple password was cracked in, you know, like 10 seconds or something. All right, so there's how you compile a program from source code. Now let's talk about the libraries and things that source code often needs to run. One thing that you need to understand about source code is that when a programmer is creating source code, they're not writing every single piece of code from scratch. They're reusing things that have been deemed to be common to a lot of different programs, and these things that are common to a lot of different programs are extracted away and put in what we call shared libraries. All right. Now, these shared libraries exist all over in the system. All right. One of the places they exist is in the /lib directory. And if you go in there and do an ls, you'll see a whole bunch of files in here. Okay. Now, one thing I want to point out is what these names mean. All right. And I don't know what all these different libraries do, but I'm just going by the file names to show you something here. So like libnns dot dash underscore files dash 2.3.2.so. So the name of this library is libnns files. The version is 2 is the major version, 3 is the minor version, and 2 is the patch. And then .so just represents that it's a shared object or a shared library. Okay. Now, what happens here is actually the file that gets incorporated into a program would actually be referenced as libnnsfiles.so.2. The 2 on the end here represents the major version of this library. And then if you do an ls-l on this directory, you would see that this one here is a symbolic link to this one up here. Okay, so this one up here, the 2.3.2.so, is the latest version of this library, but this is a nice clean way to reference it, and so you just have to bring in, you know, this particular library .2, which is saying the major version 2, and then that points up to this 2.3.2 object, which is the latest one. If another one came in like 2.4.0, then so.2 would point to 2.4.0, and you wouldn't have to change your code at all, right? You wouldn't have to recompile programs or anything like that. Just the symbolic link is the only thing that would need to change. All right, so that's the way that that the libraries are named. That's the way that they're accessed and kept track of. Half the things in each of these directories are symbolic links to the latest actual shared library. Now, another place where libraries live is in user-lib, and if we go over there, you'll see another whole slew of libraries scrolling up the screen. Just going to hit Control-C there. Another place that they live is in the X11, user X11 directory. These are all libraries for X Windows programming. Okay, so anything that has to do with X Windows, those libraries are in here. All right, so that's basically the locations of the shared libraries, the 3 million locations of shared libraries, and that's how their names are decrypted. Now let's look at how do you determine which programs use which libraries, and how do you set library paths and things like that. Now let's go back to the op directory, the John 1.6 directory, the run directory, and let's look at the John executable and see which libraries that uses. So the command to do that is the LDD command, and then you follow that by the name of the executable. So I'll say LDD John here, and that will tell me which libraries the John program uses. Now you can use LDD on like any Linux command, like bin ls for instance, and there it tells you the libraries that are used by the ls program. All right, so that's how you determine which libraries a particular program uses. Now, something that happens sometimes is that an application can't find a shared library that it needs. All right, so all that's going to happen is it's going to give an error and it's going to exit. So if the library that the program is exiting on that it can't find, if that library is somewhere that's not in a standard place, it's not in lib or user lib or x11r6 lib or whatever of those, then what you can do is you can add it to an environment variable called ld library path. and I can say equals slash new or something. Okay, whatever that path is to the library that is in a non-standard place, then this will allow the application to find it if I add that new path to this environment variable called LD library path. Okay, so that's one way that you can fix things. Another thing that happens with relation to libraries is that sometimes shared libraries are installed manually. Often they're installed by incorporation in a package, and we're going to talk about RPM packages and so on in the next video. But sometimes you need to install a shared library manually. All right. Now, there's a configuration file in the /etc directory, and this configuration file is called ld.so.conf. And if we print that out, you'll see all the different places on the system where libraries are looked for. You can see /lib is not in this list, and the reason /lib is not in this list is because it's one of the default places. It doesn't even need to be in this configuration file. It's already one of the places that gets searched for shared libraries. Okay, so this is where this file governs where the shared libraries are on the system. There's another file in this directory, and I'm going to list it here like ld.so.star. You'll see ld.so.conf, this configuration file. There's another file in here called ld.so.cache. ld.so.cache is created, and this cache is created for performance reasons. So the cache contains information about all the libraries and all of these directories. So when you need to include a shared library, what happens is it looks in the cache to find out exactly where it is, and then boom, it goes there and gets it. And it saves the system from having to look around to incorporate this library by looking through all these different directories of libraries. All right, so when you add a shared library to your system manually, you need to make sure that this cache gets updated. All right, so maybe you need to add a path to ld.so.conf. All right, if you add a whole bunch of shared libraries and they're not in any one of these directories, then you need to add a directory to this configuration file. Just say you add a shared library, though, to one of these directories, but you add the shared library manually. Then what you need to do is you need to run the ldconfig command, okay, and you just type ldconfig at the command line, and then what it's going to do is it's going to go through ld.so.conf, look for all those libraries, and then build a new ld.so.cache file to keep track of all those different libraries. And that new library that you just added, wherever you added it, will now be in the cache, so when a program runs that needs that library, it'll look in the cache, it'll find it, and it'll execute, and everything will go along happily. Okay, so remember, you add the file to your shared library. If it's in a new directory, you update the .conf file. Then you run ldconfig, which in turn updates ld.so.cache, which is what the programs use to find the shared libraries on the system. All right, well, it's time to wrap up our nugget on installation issues. And these issues that we talked about don't just come up when you're installing Linux, but they creep up from time to time again through the whole process of running a Linux system. We started by talking about partitioning hard drives and designing a hard disk layout for your system. Then we moved on and talked about the boot managers, Grub and Lilo, and we looked at a couple example configuration files and saw sort of the necessary things to be in a configuration file to boot different operating systems. Then we started talking about installing programs from source code. In the next nugget, we're going to talk about installing software from packages, okay? But this is sort of the more primitive thing, and depending on how you interact with Linux, this could be a sort of a day-to-day basis kind of thing, or it could be something that you do, once a year or even less. All right, and to understand all this stuff about source code, you also need to understand some things about shared libraries. And we talked about what shared libraries are, how you can locate them on your system, how you can add a new one manually to your system, and then the things that you have to do to update the various configuration files and cache files in the etc directory. Well, I hope you found this nugget informative. We really crammed a lot into this one, and thanks for watching.